aerodynamic center. This is one of the main parameters which is influencing the aircraft design. So let us go with the definition of aerodynamic center. So aerodynamic center is a point where a moment is invariant with respect to the angle of attack. It means in the airfoil, the point where even though the pitching moment is varying, the angle of attack is varying, that point where the moment is invariant, that point is aerodynamic center. Let us take the point where we usually call it as lift line. Lift. Let us take this CG. It is the 1/4 wind carved by 4% of, 1/4 of the entire car. So this is a car line. This has the leading edge and this is the trailing edge. So at this point we will have the lift value. So let us take a point at the aerodynamic center point where the moment is invariant with respect to angle of attack. So this distance is separated by x aerodynamic center. X, the distance from the CG from x aerodynamic center. Now taking moment at the aerodynamic center. So we will take the moment at point between the aerodynamic center. Usually we have the moment at this CG, that is carved. So we need to find out this moment is varying or not. So from the derivation we are going to define that moment is invariant with respect to the angle of attack at the aerodynamic center. That we will derive. So taking moment of the aerodynamic center. So here moment about aerodynamic center is equal to in terms of force, momentum. So force will be lift into the distance is xac. That is aerodynamic center. This is one momentum. Due to this lift, it will produce the clockwise rotation. So here also it will produce the clockwise momentum. So next term is momentum about CG. That is momentum about CG. So this is the momentum. This is a force to the distance. This is a momentum. Now this is in terms of force vector. Now we are replacing this as in terms of coefficients. So by replacing this, so in terms of coefficient, so coefficient of momentum at the aerodynamic center, or we can divide by r the aerodynamic center. It is a combination of lift into distance and momentum of center of gravity. This is, let us take this as the equation 1. Now dividing this equation 1 by dynamic pressure, that is Q into SW. So that this equation can be written as moment aerodynamic center delta Q SW is equal to L, that is the coefficient of lift, that is the coefficient of lift into x aerodynamic center divided by C plus replacing this moment equation in terms of coefficients. So we can write as half rho v square. SW is a momentum. So we have the car into coefficient of moment at the aerodynamic center for M is equal to the equation of rho v square SW coefficient of lift into the distance, this distance x aerodynamic center, plus we can write this for example CG equal to again of rho v square SW C into coefficient of moment at CG. This is CG. This is coefficient of moment at aerodynamic center. Now we are considering this all the terms of rho v square SW, that is of rho v SW of rho v SW. Again we have the common terms like C into chord into coefficient of moment at aerodynamic center, coefficient of lift into distance from aerodynamic center, chord into coefficient of moment at center of gravity. So we can write this as coefficient of moment about aerodynamic center is equal to CL x aerodynamic center divided by chord plus this CC will cancel here, you get CM CG. So this we are getting from the portion amount about. Now differentiating equation number number 2 with respect to angle of attack. So we will call GCM AC by B alpha. That is this portion of momentum at aerodynamic center differential with respect to angle of attack. This is alpha is angle of attack. So DCM aerodynamic center D angle of attack is equal to DCL by D alpha x aerodynamic center by car plus DCM CG divided by D alpha. Right? This is equation number 3. That means the rate of change of momentum coefficient at the aerodynamic center with respect to angle of attack is equal to the rate of change of lift coefficient with respect to angle of attack in the distance of aerodynamic center divided by chord plus rate of change of momentum coefficient at the center of gravity with respect to angle of attack. So we are getting this term. So from our definition, the aerodynamic definition, the rate of change of pitching moment is invariant with respect to aerodynamic center. The moment is invariant. So it means that as per the definition, it is equal to 0. Right? So this DCM aerodynamic center by D alpha is equal to 0, which is equal to DCL by D alpha x aerodynamic center by car plus DCM CG by D alpha. So this will get 0. So it means from the equation, this for equation for DCL by D alpha and DCM CG by D alpha is the parameter that helps to understand how the pitching moment about aerodynamic center varies with lift coefficient with respect to angle of attack, CG with respect to angle of attack. Whereas aerodynamic is rate of change of lift coefficient and with respect to angle of attack. This rate of change of moment with respect to CG. Let us say these are the linear constant values. So let us say this is the A naught and this is we take this as M naught. So we can substitute into this equation finding the what is the distance of the aerodynamic center from the CG, then we can measure, right? So from we can substitute this is as A naught and this will be as M naught. So we get x AC by chord is equal to this will come minus M naught by A naught. That means it means this aerodynamic center position, that is XAC lies on linear values of lift coefficient, momentum coefficient in car. It means this aerodynamic center is lies on as a fixed point in a aeroplane.